All right, kids, here we go. Got my coffee this time. I'm so much more excited. Oh, this is going to be much more better. There's my more better English. Much more better English. Anyway, Algebra 1, Common Core, June 2015. I am Mr. Krause, but of course, I go by Mr. Key during these. Parts 2 through 4. That must be problems 25 through 37. 13 questions and we'll be done. Oh my God, it's so awesome. Anyway, hopefully you've already attempted these. Hopefully you've already tried these on your own. You can find all of my organized videos at Mr. Krause, Krause, math.com. Look for Regents Review. I've got everything organized there, nice and neat for you. Should be easy to follow, but you got to do the work. You got to try on your own, and you got to drink some of this delicious cup. See, Dunkin' Donuts loves Rochester, and we love Dunkin' Donuts. By the way, as soon as I'm done with this, get to go work out. Finally, get a workout in today. What problem are we on? Dang, where are we going? 11, 12. We're on page 12. Should have known that. All right, so the question says, graph the following function on the set of axes below. So probably you should use a table of values just to kind of get credit. And like negative 9, 9, negative 8, 8, negative 7, 7, negative 6, 6. This is kind of annoying. Negative 5, 5. I don't think maybe you need that, though. That's kind of annoying. You should know, oh, wait, yo, 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 let's back up the crazy train. Not sure what I was doing there. Anyway, I would use a table of values. Go over here, table of values. Actually, and if you looked at the table of values, okay, I'll do it. My goodness, you guys are really picky. Tab, boom, delete. Come on, delete. Up, tab, tab. All right, you son of a gun, 3. Okay, I don't know what's going on. All this garbage on my screen. So absolute value, it's over here. Doesn't like when I touch that. Man, not having luck here. X minus 3, X minus 3. You hit this, it looks like that. Make sure your graph looks like that. You can go get into the table, Control T, and get into a table of values. I'm not going to copy those down for you, but you could do that. What you need to know is it's going to come here, and then because it's an absolute value, it's going to look like a V. So it's going to look like if you created the table of values. I'm not going to waste your time copying those down because you'd be like, oh, Mr. Krause, you're boring me, dude. I was like with you, man. And then you started listing all those, that there point down there, and you bored the living the daylights out of me. Don't forget to put arrows on the end. Wow, that's a pretty straight line. I normally can't do very good straight lines like that one. All right, there it is. That's the equation. Y equals the absolute value of X minus 3. Notice it was a shift to the right 3. Remember, when you add or subtract on the inside of the, actually I think that's coming up. Inside of the parentheses are absolute values, it moves to the right 3. Explain how the graph of this changed. So this is the normal graph, and this is a translation. So y equals absolute value of X minus 3 is a translation to the right 3. I think that's about all you have to say. All right, let's move on. That's 1 down, 12 to go. Another town, one more show. Alex is selling tickets at a school play. An adult ticket costs $6.50, while a student ticket costs $4. Alex sells X tickets and 12 student tickets. Write a function f of x. By the way, if you don't write f of x equals, what? Let's do that. How much Alex collected from selling tickets? Let's see. So for the adult tickets, he did 6.50 times x plus 12 times $4. All right, or you could write f of x equals 6.50x plus 48. You've got to be kidding me. Okay, that problem's on this test, and then there's going to be a problem later that, like, my trig students would have a hard time with. New York State. That's like 7th grade, 6th grade math right there. Anybody could do that one. Gosh. Let's move on. Okay, so this is one of those videos. You'll notice I got a slightly different top on today, I think. But this is one of those videos I had to redo because the video and the audio were completely out of sync. You would hear me talk, and it would be totally out of sync. And that's annoying. Anyway, John and Sarah, oh, the lovely John and Sarah, are each saving money for a car. The total amount of money they will save is given by the function 60 plus 5x. What? And Sarah will be saving function x squared plus 46. How many weeks x will they have the same amount of money saved? Explain how you arrived at your solution. I'm thinking John's never going to be able to buy a car because, yeah, if you start with $60 and you save $5 a week, it'll take you like till you're my age to get a car. You'll be like, oh, I'm almost 50 years old. I can buy a car now. Explain how you arrive at your answer. So, let's start with a simple explanation. So, in order to solve this problem, I need to set the two equations equal to each other. I don't know if they want any more than that. That's a good explanation. I'll just do it. Let's just do it. Now. All right, so we got 60 plus 5x. That's Johnny Boy, who's never going to ever be able to afford a car. And Sarah, who will shortly find out she can't do this. Because, you know, on like week 1, she saves $1. I think it was 46. And then on week, 30, she's got to save $900. Good luck, sister. Anyway, let's set it equal to 0. We'll bring all this crap over. So 0 is equal to x squared. Now the x squared is positive on this side, so you want to make sure that stays positive. Minus 5x. And we're going to subtract this 60 over, and so that gives us minus 14. So you get 0 is equal to x. It's a quadratic, so we have to solve it. They have to multiply to negative 14, add up to negative 5, so that would be negative 7 and positive 2. Multiply to negative 14, and they add up to negative 5. Perfect. This gives me x equals positive 7. This gives me x equals negative 2. Doesn't make any sense. So they will have the same amount of money at week 7. Ka-ching! Not a bad problem. Let's check this problem out. I love when we just have to do math. If the difference is oh my God, there's a fraction. I hate fractions. Oh my God, fractions! Fractions is one of the F words you're allowed to use in my class. Like if you ever get mad and you want to yell, you just yell, oh, fraction! Yeah, we know what you mean, and you don't get in trouble. And the principal's walking by and like seeing kids yelling out, oh, fraction. They're like, oh, they're learning math. Little does he know, they're not. Anyway, so the one hard thing about this one is you got to remember to distribute this negative. And there's always going to be a negative times negative to make sure that you don't make sure you understand negative times negative is positive. So the first one we'll just copy down 3x squared minus 2x plus 5 minus x squared minus 3x plus 2. Now we'll combine like terms, so we'll go wait and wait, get put together, and then wait and wait, get put together, and then wait and wait, get to put together. That's kind of cool way to do that. That's not, whatever. So I get 2x squared, and then minus 5x, and then plus 7. But it said to that we have to multiply it by, now I don't know why we want to do this, but we're going to multiply by 1/2 x squared. So we're going to take this whole thing and we're going to multiply by 1/2 x squared. So now we're going to distribute this thing. So 1/2 times 2 is 1, and we get x to the 4th. 1/2 times negative 5 is, well, that's just negative 5 over 2 x cubed. And then 1/2 times 7 is just plus 7 over 2 x squared. Now you can have either that answer or you could have this answer. X to the 4th minus 2.5 x cubed plus 3.5 x squared. Either one of these is acceptable answers. Although I hate decimals, I like fractions. You know what I like more than fractions? Really not much. But I do enjoy a cup of Dunkin' Donuts coffee when I'm doing my math in the morning with my students. So exciting. But they're not paying me any money. So I just drink their coffee for free. Actually, it's not even free. It's costing me money to buy the coffee to get the commercials. Wait a second. What up? But I am enjoying it. All right, let's go. Come on. Enough of my commercials that aren't making me any money. But that's okay. I do them just for pro bono work. All right. Let's see what we got here. Dylan invested $600 in the savings account at 1.6% annual interest. He made no deposits or withdrawals on the account for 2 years. The interest was compounded annually. Find to the nearest cent. Ooh, that's going to become important. The balance after 2 years. Well, I hope your teachers went with you and told you that we'll go f of t in this case since it's time is equal to start amount 1 plus interest rate and this has to be a decimal, and that's one of the things that's hard about this problem because kids kind of screw that up, and then to the time. So there's your formula for continuously or compounded continuously or compounded annually, compounded annually. All right, so we have to do, let's first create the equation, f of t. Our starting amount was $600. That's a nice starting amount, $600. 1 plus, we're going to come back to that, to the t. So let's talk about 1.6%. Let's do a little mini lesson. It's going to be really short. Don't fall asleep. You guys know that 20% is equal to 0.20. Yeah. You know that 10% is equal to 0.10. So now that we get below 10%, this is where it starts to cause problems for kids. Like 5%. Would you say that 5% is 0.50? You wouldn't, would you? And then would it make you feel better if you said 0.5? It's the same thing. That's 50% interest rate. So as soon as you get below 10, you now have to go, okay, 0.0, and then what is the interest rate? Oh, 0.05. That would be 5% interest rate. Because remember, the decimal gets moved twice. Decimal gets moved twice. So if I move this twice, I get 5. So if I had 1%, then that would be 0.01. If I have 1.6%, if you ignore the 0.6, again, you would write 0.01, right? And then we just tag the 6 on at the end. So that's 1.6% as a decimal. Little mini lesson for you. So we come back and we go, okay, 0.016. So there's our equation. You can either use that equation or you can actually combine those two and do 1.016 to the t. Either one of these equations will work, and we're just going to plug 2 in. So f of 2 is equal to 600. I'll just go back to my original 1.016 to the 2. So I come back over to my calculator, go into calculator mode, go into calculator mode. I go 600 times, parenthesis, 1 plus 0.016, parenthesis, and they said 2 years, squared. 619, I'm going to write it all out, f of 2, 619 point, I know it's 3536. So they want it rounded, so the answer is, what's the question? Find the nearest cent, the balance. So the balance in the account would be $619.35 to the nearest cent. Oh my gosh. All right, stop. I got to stop. Well, I forgot that I got to stop like every 2 problems, otherwise I have problems with the video again. But I was okay. I lucked out. So all right, so this problem's not a bad question. Not a bad question. If you remember one thing. So I want to make sure we understand. We need the smallest integer. And what that means to you is no decimals or fractions. More importantly, no decimals. We need a whole number. No integer, no fraction. So let's take this sucker down here and solve it. Minus 3x plus 7 minus 5x less than 15. So I get negative 8x plus 15 is less than, why did I write 17? Oh, negative 8x plus 7 is less than 15. I don't even know what I said. So then we're going to subtract 7. And you're thinking, wow, this is a really easy question. And it actually really is an easy question. Except, now, you just got to be real careful. So we're going to divide by negative 8. And this 2 things you got to remember. Well, there's two tricky parts of this problem. The first thing right now is when I divide by negative 8, I have to remember to switch that sign. So here's the solving of the inequality. But I'm not done yet. The question says find the smallest integer that makes this true. And so many of our kids that 1 year just put in, okay, x is equal to negative 1. That's not true. X, there is no equal to right here. So there's no line underneath here. This line does not exist. You see this line right here? It does not exist. If that was there, you'd be right. But it's not there. So the answer to the question is you need the smallest integer that's bigger than negative 1. So if I was listing out my integers, I go negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, ... Well, where's the biggest integer, the smallest integer, but it's got to be bigger than negative 1. It's right here. It's 0. So the answer to this question is x equals 0. That's the answer, not this. Okay? So a couple tricky parts of that problem. Oh, I hate these questions. So the residuals from a plot of 2 sets of bivariate data are graphed below. You got graph A, which is all over the place, and you've got graph B, which appears to have a pattern. And normally, patterns equals no good. So if we see a pattern, see how we have like this parabolic pattern? Right? So pattern for you is going to equal no good. I think I just put that behind my head. See, no, and I wrote goo, not good. Because there's no goo, no gooey. So when it says explain using evidence from graph A or B, which graph indicates the model for the data is a good fit, graph A's model is a good fit because it doesn't have a pattern. So graph A model is a better fit of data since the residuals don't graph. Wait, the residuals graph, that's what I meant. The residuals graph is not a pattern. It does not have a pattern. Have a pattern. All right. Not going to lie, not my favorite kind of questions. Let's see how long we're going. That's good enough. Bye. I'll be right back. And you're not going to know I'm right back because it's going to be like 2 seconds. It's going to be like, bleep, and then I'll be right back. But for me, it's going to be like 2 minutes. All right, bye. Or maybe 1. Bye. No, really, bye. And just like that, I'm back. All right. We're ready to roll. Sorry about that. I don't know. It doesn't really matter to you. It matters to me. It's sort of annoying to me. So a landscaper is going... No landscapers, by the way, make rectangular flower beds. They make these all creative things, but... That's calculus, not algebra. So you guys will have to worry about that when you get in like calculus. They'll have that. They'll have a excuse me, a flower bed that represented by the following trigonometric, radicalized, crazy equation. Blah blah blah. Not today. So we're going to round in the nearest tenth of a foot. We'll come back to that later. The area of the flower bed has to be 34 square feet, and the bed such that the width is half of the length. This is a great example of something to do in trig or on your essay too. See, most kids will do this. They'll say, okay, the length is here and the width is half of the length. I don't like that. I got a better way to do that because, quite frankly, as soon as I write this, about at least 2/3 of the class goes, oh no, fractions. I effing hate fractions. So let's avoid them. Let's do it a different way. Let's say W represents the width. Well, how can I say it a different way that the width is half of the length? If I turn that around, can't I say that the length is twice the width? Right? So let's think about that. The width is half of the length. So the length is twice the width. Think about it this way. You're half your father's age. Or, in other words, your father is twice your age. So we're going to just reverse it. We're going to say, okay, the width is W. The length is twice as much, 2W. That's it. That's the easiest way to handle it. So it says, the area of the flower bed is 34 square feet. Find and solve an equation to determine the area of the flower bed. Well, the easiest way to do that is just take length times width. So width times 2W is equal to 34. And that is all I really have to solve. Excuse me. So you get 2W squared is equal to 34. Divide by 2, and I get W squared is equal to 17. You're going to take the square root of both sides, and you get W is equal to, that's ridiculous, 4.123,105. 4.123,105. And the answer is, round to the nearest tenth of a foot, 4.1 feet. Now, there's another way. If you, man, I'm losing my voice. If you did use the other equations, by the way, let's say you chose to use the other equations, you'd say, okay, 1/2 length times length is equal to 34. So I get 1/2 L squared is equal to 34. Now you can either do what I do and multiply both sides by 2, or you can divide by 1/2, but that's the same thing. 1/2 and 1 or 2 go away. So I get L squared equals 68. Now I come through and I take the square root of both sides, and I'm going to get the square root of 68. So the square root of 68. And I'll show you why I'm doing this both ways in a second. And I get 8.246. 8.246,210, I believe, are the next ones. 211, whatever. And it said round to the nearest tens place. I'd get L equals 8.2. See how it's half? But what's the right answer? What's the wait a second? What's the right answer? Is it the width or the what are they? Oh, wait a second. Write and solve an equation to determine the width. So if you did it with the half, you ended up with the length as your answer, but the actual answer is width. So we have to say the width equals 4.1. Make sure you answer the right question. All right, one more. Let me see. Do we have time for one more? I think we do. Yep, we do. All right, so now we are into part 3, and these are 4-point questions. So these aren't quite as easy. You got a little bit of work to do, a little bit more work than the part 2. It's not like a part 6 question, but it will be difficult. So Albert says that the two systems of equations shown below have the same solutions. Determine and state whether or not you agree with Albert and justify your answer. Now this justify your answer, you can justify using math. And that's why you're in a math class. So we're going to justify using math by using math. So we're going to look at the two equations. And as I look at this one, this system seems a little bit easier to me. So I'm going to take it and I'm going to solve for y. So I get negative 8.5y equals negative 51. I'm going to divide by negative 8.5, divide by negative 8.5, and I'm going to end up with y equals, not really sure, it's probably somewhere around 6. Negative 51 divided by, that's a minus by the way, divided by negative 8.5. Now I could have left both negatives off because two negatives make a positive, and the answer is 6. So I end up with y equal to 6. Well, I'm going to take that and plug that into that other equation. Let me get a different pen, which is, now let me do all this in blue, and then I'll do the other one in. So I get 8x plus 9y equals 48. I'm going to plug that into there. And I get 8x plus 9 times 6, which is 54, equals 48. 8x plus 54. I'll show all the steps. When I get in trig, I don't show all these steps, by the way. I just fly right through it. Better pay attention. Better know what's going on. So I get 8x is equal to 6. Uh-oh, must be wrong. I think young lad is wrong because I just got a decimal, and there's no such thing as decimals in the real world. X is 0.75. Weird. So based on the second system, we got y equals 6 and x equals 0.75. Well, since these two equations are the same, it would appear that we're in pretty good shape, but I'm going to check it anyway because I think that's going to be safer. So let's check system 1. We'll check system 1. I'll do it in red. So now let's do system 1. And all we really got to do is check that these two values work. So we're going to do 8 times 0.75. Gotta love Cortana. Plus 9. Hey, Cortana. See, she doesn't come up when you call her, but when you don't call her, she shows up all the doggone time. 9 times 6, and we want to see, does that equal 48? Now, I could just do this in my calculator, but this is... Somehow that's not right. Because this wasn't going to work. Do y'all see my mistake? It's right here. It's right here. God love mistakes. This should be negative. Maybe I should have used my calculator, and that should have been negative. So my actual answers are negative 0.75 and 6, because this was not about to work out. And it should have worked out since these two equations are exactly the same. It should have worked out, and it was just about not to work out, because I was about to get 6 plus 54 equals 48, and I'm thinking, wait a second, that's not going to work. But if this is negative, this is negative 6. Negative 6 plus 54 is 48. So 48 equals 48, and check. So, whoo, man, glad I found my mistake. Should have looked down at my answers. I think I made that same mistake the first time. So 12x plus 5y. So 12x plus 5y equals 21. So we're going to do the same thing. We're going to sub in here. So 12 times negative 0.75 plus 5 times 6 equals 21. This is negative 9 plus 30 equals 21. 21 equals 21. Check. Now, I haven't yet answered the question. I have to say, it says determine and state whether you agree with Albert, justify your answer. So you still have to answer the question. I agree with young, what's his name? Albert. The solution of both solutions of both sets of equations, both sets of equations are the same. Therefore, he is a math god. Well, what did I say? Genius. Some people don't like math god. Anyway, that's it. Moving on. Oh, we got to stop. I'll be right back. Hey, that didn't take too long. For you, it was like a second. For me, it was like a minute or two. All right, we're on question 34. So 34, 35, 36, 37. 4 questions left, kids. 4 questions left. All right. Anytime you see one of these kinds of things, I don't know why that came up like that. That was weird. It's called a piecewise function. Piecewise function. Now, these used to only be taught in pre-calculus, but now we decided that 9th graders could handle 11th grade math, so we'll just do that way. And actually, it's 12th grade math, so whatever, man. You guys are geniuses. All right, so the equation to determine the weekly wages of an employee at the Hamburger Shack. What a boring name for, come on, New York State. Get creative. How about the Krause and Nacker Shack or something cool like that? The Hamburger Shack. Whatever. Anyway, where W of X is determined by the number of hours worked. Now, if you're a good math student, you should be able to look at this and see what's going on. But most of you, since you don't work, may not understand exactly how work goes. But the normal work goes this. If you work 40 hours or less, you make a certain wage. If you work more than 40 hours, you work what's called overtime. And if you work overtime, a company has to pay you extra to work overtime. Now, I'm not sure exactly how true that is anymore, but it's generally true. And so it looks like here I'm going to make $15 an hour for everything that's over 40 hours a week. Now, do you have to understand that exactly to do this problem? Not really. Not really. But you do need to understand how piecewise functions work. So it says determine the difference in salary in dollars for an employee who works 52 hours versus one who works 38 hours. So, employee number 1 is going to work 52 hours. Well, where is 52 hours? It's not between 0 and 40, so we have to use this equation. So we will use W of 52 is equal to 15 times 52 minus 40 plus 400. And if you type that in your calculator, I think it's 580, but I'm not exactly sure. We'll go 15 parenthesis 52 minus 40 parenthesis plus 400, not 4,000, 400, $580. So it'll make $580. So employee number 2, let's do this in a different color. That's too boring. Employee number 2. He's working 30. I don't remember. Is it 38 hours? I'm looking down on my sheet now. 38 hours. 38 hours. So 38 hours is between 0 and 40. So we'll use this straight up simple equation, 10 times x. So W of 38 is equal to 10 times 38, and I hope you know that that is $380. So do we answer the question? It says determine the difference in salary in dollars for an employee. So the difference in salary would be the difference in salary would be $200. So it says determine the number of hours an employee must work in order to earn $445. Well, the most I can make, so if I work 40 hours, I make, now you got to explain your answer, so let's just explain it this way. Make 40 times 10 or 400 or $400. So I must work over 40 hours. And because of that, we're going to use the second equation. So I have to use the second equation. So I must use the second equation. Now, I'm not really sure if you had to go through all of this to get the full credit for this, but you should have to explain what's going on a little bit. So we're going to say, okay, we want to make $445. It's equal to 15 times x minus 40 plus 400. So if I distribute the 15, I get 445 equals 15x minus 600 plus 400. So I get 445 equals 15x minus 200. I'll add the 200 over, and I get 645 is equal to 15x. I know the answer, but let me just make sure I did the right math. And you get 43 hours. So x equals 43 hours. So she would have to work 43 hours to make $445. Now, I didn't say you had to do an algebraic approach. So you could have just gone through and done, okay, what happens if I make, sorry about that, what happens if I work, 41 hours? What happens when I make 42 hours, 43 hours? And you could have done a guess and check like that as well. All right, I don't know if we got time. Nope, we're going to stop, and I'll be right back. Well, I'm getting pretty good at that. It's getting faster and faster. Luckily, this is the last test. 35, question 35. An online electronics store must sell $2,500 worth of printers and computers per day. Each printer costs $50 and each computer costs $500. The store can ship a maximum of 15 items per day. So they give us some room there. On the set of axes, it looks like we're going to use printers as our X value. So we'll call that P. And computers as our Y value, and we'll call that C. Let's see what we got here for a graph. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hopefully I don't have to go over 15. Well, 15, well, the most amount of printers, the most amount I could do any day is 15 combined, so I couldn't do 15. I guess I could do 15 of one. That would be kind of silly. 1, 2, 3, 4, 5. So I guess the highest I would have to go is 15, so that would make sense. 1, 2, 3, 4, 5, 10. I didn't even create my equation yet. 1, 2, 3, 4, 5. Oh, this one's going to 20. I thought it was taller than it was shorter. Did I do something wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whatever. It is what it is. All right, so let's talk about these equations that we have to solve. You have two equations we have to solve. We have an items equation, and we have a money equation. Now, the item equation is not bad. We're going to take the number of computers plus the number of printers, and it has to be, less than or equal to 15 items, because the most items I can sell is 15. Now, on the y-axis, this is normally the y-axis, right? In this case, we're using computers. So I want to solve these equations both for C, since computers is my y-axis. So C is less than or equal to negative P plus 15. So we're going to graph this equation first. So the y-intercept is 15, and my slope is negative 1. So I'm going to go down 1 over 1. Just going to now, because it was a less than or equal to, that means I need a solid line, not a dotted line, but a solid line here. If it said you have to stay below 15 items, then it would be a dotted line. But what it said was, and I'm terrible at drawing lines like this, what it said was the maximum number of items that can be shipped is 15. It's also an inequality, so we have to shade. So we need to stay below this line. We can't send more than this many items. Now, so that would be the solution set for equation 1. Now we're going to do the money equation. I'll switch colors. We'll go to orange. Now the money equation is a little bit trickier, and that is because we're going to sell $500 times the number of computers plus $50 times the number of printers, and that we need to be greater than or equal to $2,500. Make sense? Money from the computers, money from the printers, and we need it to be over at least $2,500. All right, so again, because C is our y-axis, computers are y-axis, we're going to solve for C. So I get 500 C is greater than or equal to negative 50p plus 2,500. Now we're going to divide by 500. And I get C is greater than or equal to negative 1/10 P plus 500. So, all right, that's not bad. Our y-intercept, no, not plus 500, plus 5. 500 would be a problem. We couldn't graph 500. 2,500 divided by 500 is 5. So our y-intercept is 5. And our slope is negative 1/10. So we're going to go down 1 over 10. down 1 over 10. I think that's why they had to go out to 20 there, just so you can look at that so it looks nicer. Now I got to graph. Again, it's greater than or equal to. Now I got to try to graph this. Without a straight edge, this is virtually impossible for me. And let me get rid of my little X line. Now, it's an inequality, so I have to shade. In this case, because we want to go above 2,500, we want to shade up here. Now, let's see. What does it say? On the set of average graph the system of inequalities that model these constraints. Okay. Determine a combination of printers and computers. So it has to be printers and computers that would allow the electronic store to meet the constraints. Explain how you obtained your answer. So first thing I'm going to do is pick something that works. And I know that in here, anything in this area right here works, right? So this is like where you'd have to put your solution set oftentimes, right? So I'm going to pick any point. I'm going to pick this point right here. No, I'll pick this one. It's a lot easier. So that would be 5 printers and 1, 2, 3, 8. Excuse me, 8 computers. So 5 printers and 8 computers. Why did that dot come down? So 5 printers and 8 computers. I'm going to check it. 5 times 50 will be 250. 8 times 500 would be 4,000. So that would be $4,250. Now the question says, explain how you obtained your answer. I chose a point in the solution set S from above and checked to see that it worked. All right, we're doing the one problem at a time. That's the end of that problem. Yes. I'll be right back. Alrighty. 2 problems left. We are now on to 36. Oh my gosh, all this crazy math. All right, so an application developed. Oh, I like this question. This is actually a really good question. Well written question. Love this question. It's kind of more meaningful, especially for you guys nowadays. And it kind of makes sense. So an application developer released a new app to be downloaded. God, don't you guys wish you could just come up with one of those dumb apps, make millions, and be like, done. I'm done. I made millions. Or you can sell it to Zuckerberg for like billions of dollars and be like, oh, now I'm really done. Anyway, the table below shows the number of downloads for the first, it's kind of important, first 4 weeks. So these are weeks after the launch of the app. Write an exponential equation that models this. All right, so now we got to go to our calculator and do exponential regression. So on this calculator, you have to use spreadsheets. By the way, this is an amazing calculator. It's really convenient to use. We'll come up here and we'll call this weeks. That's our X value. And we'll call this D for downloads. That's our Y value. Some people just use X and Y. X and Y usually get you into trouble sometimes. All right, so this is just 1, 2, 3, 4. That's not bad. The most mistakes made on this is not typing in the correct answers. It's so easy just to miss a number and screw up. Do these problems twice. I know it's time consuming. Don't just look at your number and go, oh yeah, I got that right. Oh, yeah, I got that right. Do the problem twice. Erase it. Erase what you got and start over and do it again. Check it over again. Let me check these. 1, 120, 2, 180, 3, 270, 4, 405. Check your work, okay? So we go menu. And we need to do exponential regression. That's down here somewhere. It's letter A in this case. We're going to do a letter A, which is exponential regression. Our X list was weeks. Our Y list was days, or not days, but downloads. And we click OK. So there's our exponential model. A is 80. A equals 80. And B equals 1.5. No rounding here, kids. I was wondering why they didn't say rounding. Now, you do see this word right here? This word gets so many kids in trouble because they see this. And they go a times b to the x. They'll go a times b to the x. And they'll go, okay, 80 times 1.5 to the x. That's not an equation. That is an expression. You need to have an equal sign. If you don't have an equal sign, it's not an equation. And therefore, you're going to lose credit. So always, 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 at a minimum, write y equals. I will always expect my kids to write f of x. I just think it looks more grown up. You guys know function notation. So I'll do f of x equals a times b to the x. And so f of x is equal to 80 times 1.5 to the x. So there's my answer to the first question. So this one now it says, use this model to predict how many downloads the developer would expect in the 26th week if this trend continues. And this says round to the nearest download. Okay, so all we really got to do is find f of 26. So we're going to do 80 times 1.5 to the 26. And we'll type that in our calculator because it's kind of a big number. 80 times 1.5 raised to the 26th power, somewhere around my salary, 303.0140. So 3030, I think it was 140.195. So use it in the 26th week, there would be 3,030,140 downloads. Sell them for $1 each. $3 million right there. Of course, Apple would take its cut, or whoever. Would it be reasonable to use this model to predict the number of downloads per 1 year? Explain your reasoning. Well, 1 year would be f of 52. Now, if you tried to do f of 52 on your calculator, which is the same exact equation, except with an exponent now of 52, you're going to find that your calculator, oops, pretty much is going to give you a bogus answer. Oh. Let's see. It didn't actually give you a bogus answer. So let's write that down. 1477, 187, 0039. So let's see. Hundreds, thousands, millions, billions. You'd have 114 billion. What is everybody going to download it 4 times on their... I mean, I think there's only like 8 billion people on the planet. So you'd have to have everybody download it like 15 times just to make it. So, no, this model would not be appropriate. It would be way too large of a number at the 52nd week. Something like that, kids. That was a good question, though, because although sometimes exponential models work good for short-term data, because they grow so fast, you can't use them for very long, right? Because, you know, here's an example of where an exponential model, and if you kind of look over at this equation, I'll bet you got a good, let's see if we can Let's see if we can go back and look at this data. You know, we got an R value of, well, we got an R value of almost a perfect R value. Perfect R value first, so it seems like it would be a great data, but after a while, it just doesn't work. All right, kids, that's it for that question. We got one left. I'll be right back. And then there's this question. So, some strange mathematician decided that why not give a problem that 10% of the kids could actually probably get correctly. Now, if you rock this problem out, nice job. You are a math genius. You're probably going to crush this test. If you got partially right, be excited. It's not that bad, only because we have use of the technology in the calculator. But because of all this crazy, this crazy equation, how many of y'all go, okay, I hate fractions. Now you're putting them into a quadratic. How many of y'all realize this is a parabola? And if you try to graph it on your calculator, it's not even that nice. But they did tell you where to graph to. So that's the first thing I'm going to do, because I really want to get a sense of what's going on with this graphing, with this thing. So I'm going to try to graph this thing. So I'm going to come down to my graphing calculator. And hopefully you're good enough at your calculator. See how I got other crap in here, all these ones? I'm going to get rid of these. I don't like having other things in there. It usually causes problems. So we'll go in here, and we're going to graph this thing. And the equation is control division, -1 over, why do you do that every time I hit the negative button? Negative. It's just this stupid arrangement I have here. 225 x squared plus control division. Yeah, you can't let things like the fact that you have a fractions and crazy fractions get you. Clearly this is a quadratic. It's going to be a parabola because it's got an x squared. So you know it's going to have a parabolic shape. It doesn't look like it though. And we're also talking about a football, so it's a real life problem. So I don't even need all this negative stuff over here. I really just want kind of to get a handle on that. But it also told you want to graph it from 0 to 150. See it over here on the right? Over here on the right? Look over there on the right somewhere. So what we're going to do is we're going to go into menu and we're going to change our window settings. And we're going to hit our window settings. And I want to go X min. I'm going to go 0. And no, that didn't help. Menu 4, enter 0. We're going to change. Now the maximum they want you to do is 150. So we're going to go to like let's go to 180. And I don't need negative, so 0. I don't really like having 0. I like having a little negative. I'll show you. You'll see why in a second. I like having like -10 here. And I'll do -10 here. And then, I don't know, how high does a football go up? Does it go up 50? I don't know. Maybe it goes up 50. Could go up more. Maybe we'll see. We'll see. There's a good... Now I can... See, the reason I like being able to have a little negative is because you can see a little bit more of the axes. So there's my graph. It's going to go up, and it's going to come down. So I probably need to find out what this highest point is. I can do that finding escape. Graph trace 5, and then trace the graph, and I'll just find that maximum. Eventually it's going to tell me what the maximum is. No, it didn't tell me. Oh, there it is. Why didn't it tell me? That is the maximum, 75. If you go past it, it's... Oh. Yeah, I don't know. That's not very good. So maybe I should use a different method, because actually that's not very good. I can use menu, analyze the graph, and we want to find a maximum, which is 3. I got to use my finger. I can't use this. So I click here. Said, what's the maximum in between all that? And that is the maximum, 75, 25. It's also the vertex. I don't know why this model is coming up with that 76. That doesn't even make any sense. So the graph is, interpret them. Did it tell me to find them in? It didn't tell you to find the maximum. So you need to do that though. So what we're going to do is we're going to go 0, 0. Now the maximum we said was 25 feet, and it happened at 75 feet. Now I know I have to get to 150. There's actually 30 of these boxes. I'm not going to count them for you. There are 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and this would be 30. Now we have to get up to 25, and I want to make this look nice. There's probably only 20 boxes, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Only 17 boxes. So I'm going to make every box 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. All right, that gets me up there. So I need points to graph. So I'm going to come back over here, and I'm going to go to my table, and I'm crossing my finger. There's a few nice points to graph. So 0, 0. I don't know why you're doing that. Stop doing that. 0, 0 is okay. And then, man, no. Oh, 15, 9 is good. So 0, 0 and 15, 9. And then I'm going to be here all day doing this. And then 30 is good. So 15 and 30 and 0. So it looks like every 15 is nice. So I'm going to go into menu again. Table. And edit table settings. And I want to make my increments here 15. Oops. I did. Oh, click OK. It's not liking that. Control T. I thought you could do it right there. Menu, window, no, table. I don't know. Escape. Maybe I have to do it this way. Sometimes when you use the pen, it doesn't like it. So we'll go to Control T. And we're going to go into menu, table, edit table settings, start table at 0. And table step 15. And we'll click OK. Yeah, there we go. Now it's nice. I don't know why it doesn't work sometimes that way. I don't know. So look at all the nice points I have. So 0, 15, 15, 9. So what? 0, 0. Oh. So yeah, those are 30 boxes, right? But I need to get to 115. I need to get to 150. So let's see. If there are 30 boxes and I need to get to 150, I need to make every one of those 5. So this would be 15. This would be, oh, that was dumb. 30. This would be 45. Even that's not going to work. What am I doing? Oh, every one of them's got to be 5. Because 30 times 5, every one of them's got to be 5. So this was 5, so this is 25, 50, 75. Okay, this makes a little bit more sense. 100, 125, 150. Sorry, it's getting late. It's almost 7 o'clock. So at 15, we got to go to 9. So 5, 10, 15, we're going to go up to 9. And let's keep switching back and forth. At 30, we go to 16. So 25, 30, we're going to go to 16. 2, 4, 6. At 45, we're going to 21. At 60, we're going to 24. 55, 60, we're going to 24. This is 20, 22, 24. at 75, we're going to 25. And then we're coming down. God, I hate it when it does that. It's coming down by 3 every time, right? 1, 2, 3. And then 9. And then at 150, it's the ground. All right. So I got to graph it to see how good I can do with this. So there's my football. Kind of looks like the graph I created over there on my graphing calculator. Coming to the right for some reason is much more difficult. I don't know why. So it didn't say we had to algebraically find. I don't know why that's there. That'll go away. I didn't say we had to algebraically find the vertex, but this vertex is in fact 75, 25. So the question says, determine the vertex. So the vertex, determine the vertex. I wonder if we have to do the math for that. Well, the vertex, well, if you had to do the math, it would be x equals negative b over 2a. So negative b is negative 2/3 divided by 2 times negative 1 over 225. Now that looks scary. First of all, you should know the axis of symmetry equation. And that looks scary, except that I can do it all on my calculator. Control division, negative 2 over 3 over 2 times control division negative 1 over 225. Enter 75. So this is equal to 75, and then h of 75 is 25. You can plug that in. So the vertex is, our vertex is 75, 25. Now it says, explain or interpret the meaning of this. So I don't remember this. Is it yards? Both measured in feet. So at 75 feet up the field, the ball is at 25 feet in the air. Okay, so now it says the goal post is 10 feet high and it's 45 feet away. Will the ball fall? Will the ball be high enough to pass over the goal? So what I'm going to do up here is I'm going to grab another calculator. I'm going to grab another pen, and I'm going to graph the goal post. And it didn't say you couldn't do this, so I'm going to graph the goal post, and the goal post is at 10 feet. This is the goal post. Now it says the goal post is 10 feet high and 45 yards away from, oh man, they were being tricky, kids. So we need to understand, what is 45 yards? 45 yards, I think I just misspelled that. Yards, whatever, is equal to 135 feet. Because it's 45 times 3. So really what we're checking is at 135 feet. So we come back over here and we look at 125, 130, 135 is right here. And at 135, it's only at, the ball's only 9 feet in the air. So the answer is no, it will not be high enough because at 45 yards, which is equal to 135 feet, the ball will only be 10 feet not 10 feet, 9 feet. 9 feet in the air. And I just realized something, kids. Do you see this work I did up here? Because I did this on my calculator, I really, really, really should give the grader my table of values, x and h of x. So we use 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, and 150. And this was 0 and 0, 9 and 9, 16 and 16, 21 and 21, 24 and 24 and 25. Those are numbers I got off the table. So you really should give the grader your work from your calculator to show what you graphed. All right, kids. Ugh. That's the end of June 2015, and I believe that's the last actual correction video I have to make, which is awesome. Hit the subscribe button, hit the like button. Let me know how you do. If you get 100 on your Regents exam, I put you on my wall of fame, and it's awesome. All right, kids, good luck. Good luck. Study, work hard, create flashcards, do anything you can do so that you rise amongst your peers to be successful. All right, good luck, kids. Catch you on the flip side, homies.